Now if we extend this forward and we extend this backward, meaning if we extend this forward and we extend this backward, this thing is actually this line. Try and understand. And this angle is actually this angle, corresponding angles. So when you want to know the slope of at a point for a curve like this, you actually draw a tangent and look at the slope of that tangent with x-axis. That's what we do. Meaning, if the slope is higher, then the tangent will actually be making more angles, because slope is tan theta. If slope is more, meaning tan theta is more, because we know value of tan theta increases with theta. Okay, so higher slope means inclination is high. That means this angle theta is high. So for example, if you have two lines, 1 and 2, which line has a higher slope? Line 1 has a higher slope because line 1 evidently makes higher angle with the x-axis. Okay, now see what slope is. Slope is dy by dx if we are making a graph between y and x. If you are making a graph between s and t, then slope will be ds by dt. Fine. Now we are making a graph between s and t, s being displacement and t is time. Now ds by dt is the slope, but ds by dt is physically velocity, isn't it? If s is distance, then ds by dt is speed. If s is displacement, then ds by dt is velocity. Now then we took s to be distance. Now let's start from there. I told you that the man has started slowly. If the man has started slowly, that means the speed is less. Speed is less. So this is s versus t graph. ds by dt is the slope at any point, and ds by dt is also a speed. If speed is less, that means the slope has to be less. So I drew a graph which has low slope. That means if you draw a tangent here, the angle, the inclination of the tangent with x-axis is less. So the slope is less. If it has started slowly, it has started with a lesser speed. If the speed is less, then the slope will also have to be less. So I drew the curve with lower slope. Then I said he gradually picks up and increases his speed. If he increases his speed, then slope has to increase, because speed is slope. For s versus t graph, ds by dt is slope, and ds by dt we know is actually speed. So if his speed is increasing, then the slope of the curve will increase, and at a later stage of his journey, he gets tired and again slows down. So again, if he slows down, the speed is becoming low. If speed is becoming low, so has to be the case with slope. So again the slope has to decrease. So you have to start the curve with lower slope and increase the slope and then decrease the slope. That's how I was able to draw it quickly. That's how you too have to learn. That's how you have to actually understand that this differential in case of s versus t, ds by dt, is the slope of course, and physically this is speed. If you're taking s as distance, if you take s as displacement, ds by dt would be velocity. Similarly, if we have a curve like this is velocity versus time graph. We have 2 points A and B. Velocity time graph, the slope dy by dx, here dv by dt we know is acceleration. So the question is, at which point acceleration is more, at A or at B? Now the simple way of looking at it is, you just try and draw the tangent at A and B. When you do enough practice, you don't have to actually draw the tangent, it will be visible to you. Now this makes an angle theta 1. The tangent at B, this makes an angle theta 2. Now it is quite clear that theta 1 is greater, this angle, because the inclination is high. This tangent at B, the inclination is low. You can see that. So the angle theta 2 is less than theta 1. So tan theta 1 would be greater than tan theta 2, because tan is an increasing function.
Greater the angle, the tan of that will be greater. Tan theta 1 will be greater because theta is greater. Slope, which is tan theta, will be greater at A, and slope actually is dy by dx, in this case dv by dt. So dv by dt is actually acceleration, slope is acceleration for the curve of v versus time. So slope at A is greater, that means acceleration at A is greater. That's how we see. We'll solve one more problem for practice and then we will summarize. Suppose this is displacement versus time graph we are looking at. This is 1, 2 second, 2.5, 3, and let's say this is 4. This let's take as 10 units, this to be 20,